Welcome back, fellow tech people, and thank you for returning for part 2 of this exploration of what APIs are, how they function, and how they serve as an integral tool when testing applications. These are concepts I studied hands-on while completing the Quality Assurance Bootcamp at TripleTen, where API testing became a core part of understanding how modern applications communicate and how QA ensures reliability. Based on what we learned in part 1 of this video, we now have a better understanding of what APIs are and why QA relies on them. First up, we'll look at the most common request types you'll encounter while working with API platforms like Postman, then we'll move on to headers and parameters, and before wrapping it all up, we'll break down what all the status codes mean and what they tell us as testers. Let's jump in. As mentioned before, we'll mostly be working with REST APIs. In REST APIs, there are 5 main HTTP methods: GET, POST, PUT, PATCH, and DELETE. These 5 requests are the core request types taught in most QA programs, including the TripleTen Bootcamp, because they map directly to real user actions. A GET request is the most common type of API request. It's used to retrieve information from a server. Anytime you visit a website, click a link, load an image, search for something online, you're making a GET request. Using our restaurant analogy, a GET request is like asking the waiter to bring you a menu item. You're requesting information, not changing anything in the kitchen. Because of that, GET requests never modify data on the server, they only read and respond to it. A POST request is used to send new information to the server. You use POST request when you create a new account, submit a form, upload a file, post on social media, enter payment or shipping information. In our restaurant terms, this is like placing a brand new order. You're giving the kitchen new information so it can create something that didn't exist before. A PUT request is used to update existing data by replacing it entirely. For example, editing a blog post, changing a product listing, replacing entire profile information. With PUT, you're saying here's the new version, replace the old one. In our kitchen analogy, this is like sending a full dish back and asking for a completely new one to take its place. A patch request is similar to PUT, but more precise. Instead of replacing everything, patch lets you update just a specific piece of data. For example, changing only your email address on a profile, updating a profile picture, or adjusting a single setting. Using the restaurant metaphor, PUT is returning the whole meal, while patch is asking for an extra side of sauce without touching the rest of the dish. A delete request does exactly what it sounds like. It removes data from the server. You use delete request when you delete an email, remove a photo, cancel an order, close an account. In this scenario, the waiter isn't bringing anything back this time, they're just clearing the table. So far, we've talked about what action the client is requesting. Next, we'll look at how requests carry extra information through parameters and headers, so the server knows exactly how to handle them. Headers are a specific type of parameter that provide important context for how a request should be handled. Instead of asking what data we want, headers explain how the request should be processed, things like authentication, content type, or formatting rules. Back to our restaurant analogy, headers are like training notes for a waiter. The waiter already knows how to do their job, but at this restaurant, there are specific rules: how orders are written, where they go, and how they're served. Headers tell the API, this is how things are done here. In addition to headers, there are a few other common types of parameters you'll see in API requests. Query parameters. These help narrow down results by pointing the request to a specific subset of the server's data. Path parameters. These make the request even more precise by targeting a specific resource or item. And finally, body parameters. These are used with POST and PUT requests to send data to the server. Together, these parameters give the server everything it needs to understand the request, process it correctly, and return the right response. The first step in validating API requests is knowing what we want to get out of them. Every request we send to a server comes back with a response, and part of that response is a status code, giving the tester a quick summary of how the request was handled. Those status codes give QA valuable insight into where the software is working as intended, where it isn't, and where it might need improvement. First, we have 100-level status codes. These tell us that the server is still processing the request. In some cases, that's completely normal. In others, it can point to inefficient logic or processing delays that are worth investigating. 200-level status codes. 200-level status codes indicate that the request succeeded at the task it was given. It's easy to assume that a 200 always means a pass test, but that's not always true. When QA is testing the boundaries of an application, we're sometimes verifying that certain actions aren't allowed, and in those cases, a 200 actually could signal a problem. 300-level status codes mean that additional action is needed to complete the request. The request itself may be valid, but the resource could have been moved, been cached, or redirected. These responses often lead QA to take a closer look at the application's navigation and routing logic. 400 level status codes. These point to client-side issues such as incorrect input, missing resources, or attempts to access restricted content. And again, a 400 doesn't always mean a failed test. In boundary and negative testing, QA may expect those responses. And finally, we have 500 level status codes. These place the responsibility on the server itself. These actually warrant resending the request to confirm the issue and to rule out formatting errors before identifying as a server-side failure. As mentioned in the first video, API testing is direct. And using API requests allow us to create more targeted, more efficient, and more comprehensive test coverage, all without ever having to formally interact with the application's user interface. They give testers a direct line of communication with the server, almost like a backdoor that lets us focus on how the system actually behaves under the hood. And once again, they're more efficient. Instead of repeatedly loading a page, typing in every possible variation of a username, and manually checking which ones are accepted or rejected, we can generate a structured set of API requests. With a small, simple change to each request, we can simulate the same user action again and again, while collecting clear, consistent results from each response. This approach to testing saves time, reduces noise, and helps QA teams spot issues in the core logic of an application long before they surface in the user interface. I hope you'd enjoyed the second part of our journey through the silent but essential role APIs play in our daily digital lives, and how they can be used to test the backbone of software while it's still in development. Everything we covered here, from understanding REST requests to validating responses, reflects the hands-on, real-world testing approach I learned through TripleTen's Quality Assurance Bootcamp. If you'd like to learn more about your next career in tech and how to get there, click the link in the description to get started. Thanks for watching, and happy testing!